I'm a 70s kid. In the 70s, it was still pretty magical to be able to turn on a little box and hear voices coming out of this little speaker, and radio, electronics, computers, technology of this nature was magical. It still is magical. My first experience with a computer probably would have been in the early 80s. What was really intriguing about computers was you had full control over something. It was kind of empowering, for me at least, to be able to imagine something, think about what logically would make that happen, program it in, and see it occur. I had an opportunity to go to a community college and take a digital electronics class and really begin to understand how this fantastic machine that I was having so much fun with actually worked internally. And I began to use the math that I had learned and understand the laws that governed all this phenomenal technology at the time. Everything that we do in electronics, ranging from power distribution to radio communication to launching satellites to high-tech photography equipment and image processing and communications networks and so on, all comes down to some very basic principles, very simple math. Math is and has always been an abstract field. That is, you visualize numbers and relationships with numbers and properties of things, and you can relate them with equations and so forth. So it's very abstract. The devices that we use and have in the electronics world today, there's a lot of stuff going on in there at a very, very fast rate, and it's very difficult to physically see anything happening. You pull your phone out and you're doing something with it, with an app or whatnot. There's millions of calculations going on every second, and you can't physically see that. So you have to think abstractly, and math really helps you to develop that mindset. Having a mathematical mind will help you to understand how things work that you can't always physically see what's going on. Think of a smartphone, a little tiny device. It is a marvel of computing technology. It is a marvel of electromagnetic communications technology, power technology. You have a battery in there, a very tiny battery, that you want to squeeze the most energy out of that battery as efficiently as possible. All electronics, all driven by fundamental mathematical laws. Much of what we can do nowadays with technology is driven by digital signal processing. It's in all the cameras that we use. It's used for data compression whenever you talk on a cell phone and you're trying to send large amounts of information across vast distances in a short time. It's a technique whereby you're using a lot of simple equations, lots of them, in a very powerful processor to get some really amazing things done. Electronics has changed an awful lot over the years. When I was young, very young, I thought that a great show and tell presentation would be to bring in a simple single transistor and say, this is the most revolutionary thing ever, right? This one little transistor. And now the devices that are sitting in all of our pockets right now have literally billions, vast billions of these transistors doing very fast calculations, and the scale of the technology has just changed so much over my lifetime. We have a real eclectic mix of things that our graduates do. We have quite a number of them that are involved in automation fields. Factories and buildings and complex systems are controlled by devices that control when things turn on and off and move here and there and so forth. A lot of our students are very, very skilled at these semi-robotic systems where they have to know programming, they have to know how to interface equipment to one another, they have to interface computers to these systems, they have to write programs that drive all this sort of stuff. So there's quite a lot of opportunity there. There's also opportunity for circuit design. What's becoming more important in this world is to be able to efficiently harness energy, green energy, everybody likes small batteries, small devices. How often do you want to charge your phone? As little as possible. So you need people that understand and can design and work with circuits that efficiently take a certain volume of energy and make it last all day long. Every washing machine, every microwave oven, everything that has a little blinky light on it has got a microcontroller in there that somebody has to understand how to design, program, make it work, make it interface with the rest of the world. That's what our students are doing. A lot of folks think the next big thing is the Internet of Things. Everything's going to have a microcontroller in it. Everything's going to be collecting little pieces of data. Everything is going to be then sending that data to be collected somewhere. Some of the personal fitness trackers that are becoming very popular as an example of the Internet of Things, where ubiquitous devices on your body, in your environment, in your car, in your office, monitor things like temperature and heart rate and cholesterol on a moment-by-moment basis. And this data can be used to target medicines, to inform you of maybe what kind of food choices you should be making, to cut healthcare costs. These systems need to be designed, they need to be put into place, they need to be tweaked, they need to be programmed. And I think our students are being very well prepared to be part of that next big thing of the Internet of Things. Because we can put sensors everywhere, because we can collect data from everything, should we do it? In many cases, yes. In many cases, no. Engineering ethics is a big part of what we do. And it is important that students are more well-versed than just being able to do the technical things. They have to be able to relate this to the real world and see the impact of their decisions on the real world and decide and make informed decisions as to how they should implement these systems. You know, you see some of the movies that are out nowadays, the science fiction movies. You have a person standing there just waving their arms around, and there's 3D computer screens, and things are just, with the spoken word, are assembled and made in the snap of a finger. Every single day this is becoming more and more reality. You have a nexus. You have computing technology, you have manufacturing technology, 3D printing capabilities, you have amazing advances in the biomedical field and embedded sensors in the human body. And this stuff is starting to come together. What was science fiction in the 60s when I was a kid, Star Trek, that's old hat now. You know, we've got the handheld communicators, you know, we're still working on the transporter beams, but that stuff's here. We're getting there with this convergence of amazing technology.